Alright guys, welcome back to the new term, and welcome back to chemistry. I hope that this demonstrations and little experiments were a fun way for you guys to see how water interacts. And so what I'm going to do is we're going to have 3 different videos. This first one is going to be on the first chart that you see, the second one will be on the second chart, and the third one will be on this last chart. So you can kind of watch whichever videos you feel like you need. So hopefully you were able to do and watch all of these demonstrations right here, and you're able to fill in this observation section. That's just things that you notice during the video. Anything you put is right. And we're going to be talking about this explanation section on this side of things. And so again, I'm not going to be grading this explanation part super hard either, so I just want to see that you're thinking about those observations and trying to explain them using water and its polarity, and explaining why we see the things that we do. And so I'm going to go through each of these explanations. So maybe go to the ones that you don't feel as good about and listen to my explanation, or maybe do the first one listening to me and then try the next 2 yourself. However you would like to do it is fine with me. So before we jump into any of this, let's start talking about water. So I drew water over here, and you'll notice that up here there's a partial negative sign, and down here there's a partial positive. And you'll remember that water is polar. So this water has a covalent bond right here between the O's and the H's. So they're sharing electrons. But these electrons are usually closer to the O in the bond. So they usually hang out more by the O because O is more electronegative. It likes electrons more. So since they hang out closer to the O has the partial negative sign up top, and then it has these positive signs down below by the H's. And because of that, it makes water interact in a certain way. And it makes it so that the world we live in can function because water acts this way. So it's really, really cool. So lots of times in these videos, we're going to talk about hydrogen bonding. And what that is when water is interacting with other waters, they have this going on, and they have these little positives over here, and they have negatives over here, and it interacts with the other water like this. So say this is another water molecule. This positive and negative are actually creating a hydrogen bond. So it's not as strong as these other bonds between the O's and the H's, but this OH bond is a special one called a hydrogen bond, and it makes water kind of stick to itself and stick to other things. So it makes it a little bit sticky. And that's why we see lots of the results that we see is because of this hydrogen bond. Alright? So now that we got that out of the way, let's start getting into these explanations. So the first one, you watched this video, and it was this water bottle, and we saw it explode when it got cold, when it froze. And so we need to explain why it exploded. And so we know when we saw they had this glass bottle, and they had it filled up almost all the way to the top, right? All this was filled up with water. When it froze, this water grew and grew and grew and grew and grew. Oh, sorry. So this water, it kept growing, and so eventually the glass bottle couldn't contain it anymore. And so it actually shattered. The glass bottle shattered, and then we just had this ice block left that had grown and grown and grown. So we have to think about, why did we see the water expanding like this to where a point where the container couldn't hold it? And you'll notice water actually, when it creates these hydrogen bonds, or the way that it interacts with each other when it freezes, is that it creates kind of a pattern when it freezes. And it's in this very structure, this very special structure. And because it's in this special structure, it kind of spreads out. And so water actually spreads itself out. And so normally, if it's in just a normal bucket of water, all of the molecules are kind of sliding past each other and interacting in hydrogen bonds, stuff like that. However, when the water freezes, now the water has expanded, and because it has created these special structured bonds in the frozen thing, and so it has expanded to create a more structured pattern. I forgot to pull up a picture of this, but you could Google frozen water versus liquid water, and you'd see a really cool picture of this visual. So I would suggest Googling that and seeing those visuals. Sorry I didn't have one ready for you guys. So the next example that we're talking about is cracks in the road. So how do cracks and potholes form on roads? Again, this observation point, you're just writing whatever you want in there. On the explanation part, we need to answer this question. How do cracks and potholes form? And so first let's think of a road. So we have a road here, and when it rains, the water gets into the road. And if it finds a little tiny crack or somehow gets, somewhere in the road, then say that we have, winter, so it's really cold outside, these are like snowflakes, and this water that has gone into our road now is going to expand. And so it's going to expand, and it's going to kind of break open that crack. And then it gets hot again, and this water evaporates and stuff, but now our road is left with a huge crack in the middle of it. And then again, we'll see the same pattern kind of will happen over and over again. And we'll see this water come down, get into the crack even more, freeze, get even a bigger crack, and it will go and go and go and go and go until we have things like potholes form. So that's why potholes form, is from this water expanding as it freezes. So you'll notice in both of these, we're talking about water expanding as it freezes. It expands because of the structure that it creates, like a crystal kind of structure as it freezes. Again, Google a picture. Super helpful if you do that. All right, this last one, we're talking about a pond freezing. I'm sorry, in mine, the words kind of went over the picture here, but it's okay. Hopefully on yours you can see it. So we have at the top here, we see the ice. It expands, so it floats. That's why ice floats, is because we see the expansion, which is nice. Because down here, if ice melted, it couldn't insulate our water anymore. And so what would happen is we'd actually get lakes that would just all be ice. Because the ice would sink, you see it sinks down here, it starts killing things off. Then when it gets even colder, it just keeps freezing the water above it. So eventually it'd freeze the whole water, and your whole lake would be completely frozen, and we have no more fish, no more plants, things like that. And our lakes, our ponds, our oceans, stuff like that would eventually all freeze over and be a really real problem for life. And so it's important that ice floats. And again, why ice floats is because it creates this crystal structure kind of when it freezes. And because it's creating this structure when it freezes, it will all spread out and it will float. And so creating this kind of a hexagon pattern is what happens, is really, really important. So again, Google one of those pictures. It'll be really important. Your main takeaway here is that or you could say water expands maybe as it freezes. You could also write H2O if you want. You could talk about it being like less dense if you want here, or other things like that. Just the main takeaway is just that you can kind of see how all of these demonstrations were grouped together. All right, I'm going to make a video for the next one and the next one, so watch what you need to. But we're going to be talking a lot more about this hydrogen bonding up at the top here.